We are now on question C of O-Level Recap under Tutorial 2. This question wants us to prove the identity, where on the left-hand side it is a rather complex expression, and on the right-hand side it is simply tangent to theta. If we were to see this in our exams, how would we approach this question? Would we want to prove from the left-hand side to the right-hand side, or from the right-hand side to the left-hand side? Well, typically we like to prove from the side which is more complex. This is because it would be easier for us to simplify. So in this case, let's start from the left-hand side. So the left-hand side is equals to sine theta minus sine 2 theta plus sine 3 theta, all of which over cos theta minus cos 2 theta plus cos 3 theta. And then at this point, how do we proceed? Well, we do notice that the numerator consists of many sines and the denominator consists of cosines. In our minds, we do know also that tangent to theta can simply be written as sine 2 theta over cos 2 theta, meaning to say that we kind of want to keep sine 2 theta and cos 2 theta. Therefore, perhaps we could put all the terms that we want to get rid of on one side. This would mean to rewrite our fraction to be as such. All right, minus cos 2 theta. Okay, the next thing now is how can we get rid of sine 3 theta, cosine 3 theta, sine theta, and cosine theta? Is there something in our formula sheet that we have encountered? Well, this actually looks quite similar to factor formula. In particular, we see the first equation and the third equation to be quite applicable. How is this so? We can actually let P be equals to 3 theta and Q be equals to theta. Why do we like to let P be of an angle greater than Q? It is because we have a P minus Q, and it is easier to work with positive values, right? So in the first case, if we have sine 3 theta plus sine theta, it gives us 2 sine. Half of 3 theta plus theta would be 2 theta. All right, and cosine 3 theta minus theta is 2 theta. If you take half of that, it will be theta. In the third equation, if we have cosine 3 theta plus cosine theta, all right, this would give us 2 cosine 3 theta plus theta gives us 4 theta, and if you take half of that, it gives us 2 theta. Cosine half of P minus Q, so 3 theta minus theta, it gives us 2 theta. Take half of that, it gives us theta. So we can then put it back to our official working, and this gives 2 sine 2 theta cos theta minus sine 2 theta over 2 cos 2 theta cos theta minus cos 2 theta. This is quite ideal because we do see more occurrences of sine 2 theta as well as cos 2 theta. We now have to think of a way to try to get rid of cos theta. Well, it looks like we can actually factorize out sine 2 theta in the numerator and cos 2 theta in the denominator. So this would give us sine 2 theta bracket 2 cos theta minus 1 and cos 2 theta 2 cos theta minus 1. And great! We can actually cancel out 2 cos theta minus 1 for the numerator and the denominator, which then leaves us with sine 2 theta over cos 2 theta, and this is equal to tangent 2 theta. And hence, left-hand side is equals to right-hand side. So we have proved this identity to be true. And this is the end of part C, or rather question C of this tutorial.